and welcome to IMEI video. In this video, we'll be discussing about mobile network architecture. After watching this video, you will be able to provide an overview of the mobile network architecture, describe various components of a cellular network. Let us begin by understanding what a mobile network is. In a mobile cellular network, the signals that carry voice and digital data are sent through different channels using radio waves from one device to the other. In case of a cellular network, the data is sent through a network of transmitters and receivers. Let's begin by understanding the various components of a cellular network. A cellular network consists of several components such as base transceiver station, antenna, base station controller, mobile switching center, location register such as home location register and a visitor location register, and a link to the public switched telephone network. We will discuss each of the components in detail as we move ahead. But before we dive further into the components, let's take a first look at the overall functioning of a cellular network. In a cellular network, the BTS facilitates direct communication with the cellular phones. A few base stations are then linked to a BSC. The entire unit then turns into a small center that routes call to appropriate base stations. This unit also determines the base station that is best for a particular call to process. The links used between BTS and BSC can be landline or a microwave link. Usually, BTS antenna towers also have a small micro dish antenna used to provide a link to BSC. Let us now understand the working of different components in a mobile network architecture. Let us first begin with the first component, that is a mobile equipment. Mobile equipment means a physical cellular phone that works on a cellular network. Let us now look at some features of a mobile equipment. While old phones worked on a single band, the recent phones have dual band, triple band or even quadruple band. A quad band can work on any network across all over the world. Another interesting feature of a mobile equipment is International Mobile Equipment Identity Number, IMEI number, which is used to uniquely identify each phone. The manufacturer of the mobile phone burns this number into the phone. The IMEI number can also be found beneath the phone battery on the panel. Other functions of BTS include speech encoding, encrypting, multiplexing, and modulation or demodulation of radio signals. Next, let us understand the next component of a mobile architecture. BTS refers to the antenna which is located at the top of a cellular tower. A mobile phone gains access to the cellular network through a BTS. Its main function is to enable radio communication between the cellular network and a mobile phone. A single BTS encompasses 120-degree sector of a particular area. A tower containing 3 BTSs encompasses a 360-degree sector of an area. However, on the basis of user demand, a cell can be divided into 2 or more sectors, or several BTS containing redundant sector coverage can be used to provide services to it. A cell identity is allocated to a BTS. A cell identity signifies a specific location, area with cell details of a particular BTS. Now that you understand the components much clearly, let's look at a core component, that is a cell. So what exactly is a cell? A cell contains a base station, transmitter and several radio frequencies. It provides services to a limited number of subscribers within a particular coverage area and has a radius of approximately 30 kilometers. Now that you know what a cell is, let us look at different cell size and capacity. Cell size refers to the total number of cells that can be used to cover a particular geographical area. Capacity, however, refers to the total cell capacity that is available to users. Cell capacity is limited by the existing bandwidth and operational requirements. Every network operator must handle the cell size and its capacity appropriately to handle the rising traffic demands. You can increase the capacity of a cell by making the cell smaller. However, larger number of base stations is required, which maximizes the operator's cost. Therefore, in those areas with more users, small and low power base stations are set up. On the basis of size and function, cells are classified into macro cells, micro cells, pico cells and selective cells and umbrella cells. The next component that we will learn about is the base station controller. As the name suggests, BSC controls several BTSs. It performs many other functions such as assigning radio channels, measuring power, signaling from mobile station, administrating frequency, and determining handovers from one BTS to the other. A BSC minimizes the number of connections to MSC and enables connection with high capacity to the MSC. A A BSC can be placed together with a BTS or an MSC, or can be separated geographically. Now that we know the functions of both BTS and BSC, let us learn about another important component, that is Mobile Switching Center or MSC. MSC acts as a control center for various cellular networks. It coordinates various activities of BSC and also acts as a switch and connects into telephone network. It includes different communication links such as fiber optic links, microwave links and copper wire cables. MSC performs functions such as routing of calls, setting up of calls and other basic switching functions. An MSC manages several BSCs. It also interacts with other MSCs and inter-BSC handoffs. It has HLR and VLRs and the database containing information of the last visited location of the mobile phones. MSC also facilitates authentication of mobile phones into a cellular network and the generation of billing information for subscribers' accounts. Further, it has several backup and duplicate circuits to ensure continuous operations in case of a power failure. Power backup systems ensure that the MSC does not fail. If the MSC fails, the complete network breaks down. This brings us to the end of the video. Let's have a quick recap of what we discussed. In a mobile cellular network, the signal that carries voice and digital data are sent through different channels, using radio waves from one device to the other. BTS facilitates direct communication with the cellular phones. An International Mobile Equipment Identity IMEI number is used to uniquely identify each phone. Thank you for watching the video.